Hello, this is a Chapter 4 activity we do after we've completed Chapter 4 as an extra practice. So what I did is I had my students measure their height, how tall they are in inches, and their arm span in inches as well. And we discussed as a class that we were going to make our explanatory height, how tall you are in inches, and our response arm span is going to be our y. So we're going to say, is there a relation between your height and your arm span? So let's see if there is. So before we touch the calculator, before we do anything, we determined that height is our explanatory. X, put that in list 1. Arm span is Y, put that in list 2. Again, input, height, output, arm span. Remember that because we want to make sure we know what everything means. And then before we touch the calculator, we need to figure out our window. So our shortest person was 59 inches, so maybe start at 55. Our tallest person was 72, so maybe go up to 74, 75, count by fives. Our shortest arm span was 58, so again maybe start at 55, or 56 actually, so maybe start at 55. Our longest arm span looks like 74, so maybe go to 75. So before we touch our calculator, determine your window. So I decided to go from 55, right in the corner, to 75, counting by fives for height. Arm span, I decided to go from 50 to 80, counting by fives. Determine that first. Now we go to the calculator. Now remember, we've used our calculator a lot, so we want to make sure we start there. Go to y equals, make sure there's nothing in y1. We're only going to use plot 1, so we don't want these other two on for now. But I hit stat, edit. I'm putting my data in list 1 as height, and then list 2 is arm span. Double, triple check your data. Go to second y equals, go into plot 1, turn on, choose scatter plot, x is list 1, y is list 2. Again, don't use zoom 9, we're going to do our own window. My x minimum is 55, x maximum is 75, counting by fives, y minimum 50, y max 80, counting by fives, hit graph. Okay, there's your data. Looks like a strong linear positive relationship. The taller you are, the larger your arm span. And then we're going to answer a bunch of questions related to this. So, what is the shape? Linear. Association, trend, positive. As height increases, the arm span increases. The strength is strong. But we don't like saying strong, we want the number. So we're going to find correlation. So remember to find correlations the same way we find linear regression. All the same stuff. Stat, calculate, number 4, linear regression, list 1, comma, list 2, enter. Correlation is your R, 0.83, which means it is positive and it's fairly strong. And then A is your slope, 1.09, B is your y-intercept, negative 5.71. And then we're going to explain stuff. And here's the part I really want you to pay attention. Remember, slope is output over input. So when we have 1.09, that is your output of arm span, and your height is 1, that is your height. So for every 1 inch of height, your arm span increases 1.09 inches. Now let's talk about that. The myth is that your height and arm span are the same. Seems like it's pretty close. If they were exactly the same, we'd expect 1 over 1. But maybe there's a measurement error, or we didn't round exactly, but it is pretty close. Now, when we explain the y-intercept, it's when x is 0. So negative 5.71 is our y-intercept, and we explain it as when x is 0. Now, x is height, so at a height of 0 inches, your arm span is negative 5.71 inches. Now again, sometimes a y-intercept doesn't make much sense, but if the myth was true, we would expect the y-intercept to be 0. No height, no arm span, so we're a little off there. Maybe some measurement issues, maybe there's some issues with the myth. And then our R squared is the percent of data explained by the line. So remember from the calculator, we got 0.689 rounded to 0.69. 69% of the data is explained by the line. So when I go to y equals and put that line in, remember, we're not going to have everything. The line's not going to represent everything, but it'll represent about 69% of the data. So it's not bad. There's your line. Make sure it goes through the center. And then the question is, based on correlation, does height cause arm span? Correlation cause? The answer is no. Correlation does not imply causation. Now, we can use that linear regression to predict. So if I have a height of 60 inches, remember height is 60, x, 60, plug it into our formula, we can say the predicted arm span of a height of 5 feet, 60 inches, is predicted to be 59.69 inches, your arm span. Same thing if I have a height of 72 inches. Put that in for x. We can say the predicted arm span of a person with a height of 6 feet, 72 inches, is 72.77 inches. Then we can say a height, we can predict anything. We predict the height of someone that's 8 feet tall, so 96 inches, plug it in for x. We can say the predicted arm span of a person who's 8 feet tall, 96 inches, is 98.93. But you'll notice, is it reasonable? Is it reasonable? Now, I think it's reasonable to predict someone that's 5 feet or 6 feet tall because we had that in our data. But we did not have anything 8 feet tall. There's no data to support that. So can you predict it? Yes. Would it be accurate? Maybe not. We'll get to a word called extrapolation, which talks about that. So remember, if you predict beyond your data, it may not be accurate. So for example, I can predict gas prices 50 years from now, but I don't know what's going to happen 50 years from now. And also be careful. Remember, height is x, arm span is y. So in the last question, I'm looking for height given arm span. So arm span goes in for y, and we need to solve for x. So we add 5.71 to both sides, divide by 1.09, and we can get the predicted height of 64.87 inches for an arm span of 65 inches. Okay? And it would be supported by data because it falls within our data. It's supported. So we're able to do a lot with this. And this was another review example, so practice, practice. And in 4.4, remember, there's some things to be careful of. So remember, correlation does not imply causation. Okay? Don't fit linear models to nonlinear. Remember, what we've been doing is for linear. If it's not linear, then it's different. Beware of outliers, aggregated data. Each plotted point is from a summary of a group of individuals. So what we're doing is the individual data, but you can aggregate data, so be careful with that. And extrapolation, use the regression line to predict, to make predictions beyond the range of the data, but generally extrapolation is inaccurate because we don't know what's going to happen in the future. We talked about R squared and an explanation there. In addition to all the examples we've done, you still need to practice. And there's another example here that I'm just going to scroll through that you're more than welcome to try. This one talks about sugar and rating of a response. But all the steps, everything is detailed here. Calculator steps, so please, please practice this one. The more you do, the better you'll get at it. But I have all the steps here, step by step with pictures, so please, please check that out to really get you ready for Chapter 4. There's a lot of work, and you will get it when you practice. Actually, a little bonus material there. Thank you.